Okay, this is Darius with the Comp 380 Lab 8 Belief Networks. Um, this goes over belief networks, probability, independence between variables, all that type of stuff. And question A, explain what it means when two variables are independent. Two variables are independent if knowing the result of one tells you nothing about the result of the other. This can be found mathematically as P of x, y equals P of x times P of y. Basically, what this means is that if we know P of x, it tells us nothing about whether or not P of y is true, essentially. Explain what it means when two variables are conditionally independent. Two variables x and y are conditionally independent if for another variable z, P of x, y over z is equal to P of x over z multiplied by P of y over z. This basically means that once we know the value of z, knowing the value of x gives us no more additional information about knowing the value of y. Now, question C, what is the independence assumption in belief networks? First, we got to explain what a belief network is. Belief network is a tree made up of nodes that then a node's descendants are the variables that depend on the node's value, so that whether the node happens or not, so true or false. And basically we assume that a variable is conditionally independent of all the variables that aren't either its parents, so aren't required for that variable to be true, and all of the descendants of that variable, i.e. variables whose have the same relationship with that variable as that variable does to its parents. And now we're on to the belief networks part of this. So we can just go into the solving tab of the fire alarm belief networks. So this is our belief network. We've got the tampering, fire. One of those has to happen for the alarm, and the alarm has to go off for a report. And then we have fire, and fire is required to have smoke. And either the alarm or smoke could cause people to leave the building. But we are going to make we're going to make a query of smoke first, and that's what it gives us. I don't know if this is actually correct. It probably should be factoring in the probability of fire. So it probably should be 0.75 false and 0.25 true, but this is what it gives. I'm sure there's a reason for that. But then if we make observation of fire, and fire is true. Now, if we query smoke, we get the same result. It shouldn't really be the same result, but this is correct here for this. I think it's that the previous query is wrong. And now we make observation of alarm to see if it's true. Alarm is true, and we query this. And obviously, I'll leave that up for a little second there. Same thing here. Doesn't really matter that we found that alarm is true, because alarm and smoke are conditionally independent, as you can see here by the factor that they don't have arrows connecting them. This is and this is a belief tree. So like even if it was like say if the alarm was a smoke detector, it would be a different tree, right? It would be a tree of alarm up here, but the alarm must be manual since tampering can set it off. But then if we just look at the independence quiz here, you can see is leaving conditionally independent of fire given alarm. Correct answer is false, and is leaving conditionally independent of report given alarm. Correct answer is true.